Hey, thank you for joining us at SUSECON Digital for securing your application delivery environment. My name is Andrew Gracie, and I'm joined by Cameron Cedar, and we're going to talk you through a few things that you might need to know.
Welcome.
So the first thing that we're going to talk about is an intro to DevSecOps, then go through threat modeling and attack trees. Then we're going to talk about some platform security basics, some third-party tooling, and some common ANSI patterns. What you need to know for security is huge and still getting to be known. So we're just going to be scratching the surface and hopefully pointing you in really good directions to continue learning. So containers are on the top of everybody's mind, and we're seeing a lot more use of them. As you can see from this graph that was done by the CNCF, security is the #2 challenge that we're seeing with actually deploying containers into production. We can see that there's a good mix of public cloud and private cloud, as well as hybrid use cases. So there's a lot of complexity going on, as well as just a lot of breadth of different types of problems to be solved. You can see that in the last few years, production use of containers has taken off and really caught up with development and test use. So this leads us to DevSecOps, which is basically just another term that is kind of in the ops, like star ops type tree. And so what does that actually mean? So all of these DevOps, DevSecOps, ChatOps, really all of these are really coming out of the lean manufacturing and theory of constraints model. It is really a cultural change that you have to take, basically pulling the security into being everybody's responsibility, building it into the process and the product itself. So you're actually building into the pipeline directly and failing when it's not there, failing the pipeline when it's not there, not the app. And right at the moment, there's really no best practice. We're still trying to figure this out. There's a huge amount of knowledge that we can leverage to make sure that things are secure, at least to the best of our ability at the moment. So a quick example of what DevSecOps might mean to just a kind of generic workflow is maybe your pipeline gets structured something like this slide, where a code commit kicks off your normal unit tests, but it also includes some static code analysis and audits of all of your dependencies. Then all of that gets built together. You roll in security tests along with your integration tests. And then when you do your canary deployments, you go ahead and immediately turn around and do more security tests right there. So you know as soon as there's any issues, potential issues, you know that those get highlighted, and you can go and turn around and fix those and fail faster, really. So Cameron's going to talk a little bit about threat modeling.
Thanks. Yeah, perfect. Yeah, security is awesome. I talk with a lot of companies that they have a lot of challenges by way of security, especially around Kubernetes. And some of their challenges, they tell me, are really, it's just a hard conversation, or they have developers that don't understand security in the context of Kubernetes. And so that makes the conversation hard. It makes it hard to actually implement a test model. It makes it hard for them to really understand how to go about implementing security into their workflow and really making sense of it all. Hopefully I can shed a little bit of light on that in these next few slides on how you can maybe go about that, or at least get started, because those policies and the workflows that you prescribe in your own environment are really they're going to change. They're going to change as you mature. They're going to change as your applications mature, as you implement more and more applications on top of Kubernetes. So there's an interesting study that's been done within the CNCF Foundation. There is a group, they call themselves the Financial User Group, and they've really gone about analyzing about 15 to 20 different financial institutions. And what they've done with this is they've used this as a model to be able to create a prescription, essentially, to identify specific issues, identify different types of threats to a Kubernetes environment. And so they've taken these different institutions that have different types of regulation, different types of security, and they've ran those through this security perspective, if you will. And there were two items that really came out of this that they really wanted to focus on. And one of those was what types of controls to use. And you're probably in the same boat as what they were in when they first started forming this. You're trying to figure out what controls you're trying to use, and then also how to test those controls. What's the proper way to do that? And then, of course, they also want to address the skills gap, because they found that a lot of their security guys, they had no idea how to, test security against Kubernetes or containers, or what that really meant in their environment. And they needed a way to train those people, get them up to speed with Kubernetes and the new technology. Next slide. So what controls to use? Let's dig a little bit deeper into that and how to test them. It really comes down to creating attack trees. And if you're not familiar with that, you basically need to put on your hacker hat, basically, and think like an attacker. Think like somebody that's going to do something malicious to your environment. What would you do? And an attack tree is very important. And especially when it comes to Kubernetes, where we're dealing with a cluster, whereas monolithic application stacks, you're dealing with a single application set, and it's typically running on a single machine. Whereas with Kubernetes, we're dealing with multiple machines, and we have different areas where you might be attacked. So we need to map that out. We need to map out your security controls, all your standards, put that in a map and how it relates to Kubernetes as a cluster-wide solution, and how your application stack is actually mapped on top of Kubernetes. That's going to be a very important exercise that you complete. And everybody needs to be involved, from your application developers, your security team, your red team, your blue team, your security operations center, your administrators. Everybody's going to need to be involved and get involved with those controls, those standards. And then you're going to need to enable your security operations center to help them to develop a protective monitoring policy going forward. That's going to be absolutely critical. So this is really part of your blue team. Your operations center is going to be a lot of that blue team going in and doing the monitoring, looking at logs, doing a little bit of forensic stuff. And you might have a sub team within that security operations center that's doing some of this stuff. And then, of course, adding more color to a lot of your discussions between security, between the various project teams that are developing these applications. So there's that feedback loop when we talk about your workflow. That all has to be built into your workflow. If it's not, then you're not getting the right feedback across, and your security policies are not being improved upon. Your attack trees are not being improved upon. Your pen testing is not being improved. That's all going to fail if you don't have that proper feedback. Next slide. So what I have here is a basic threat model, and this is a Kubernetes threat model. It shows all the trust boundaries. If you were to zoom in a little bit, I know it's kind of an eye chart, but you can find this out in the Kubernetes GitHub. It is located there. All of this information is. But if you zoom in on each one of the process components of Kubernetes, like etcd, the API server, scheduler, controller, kubelet, you'll notice that there are trust boundaries around each one of these components. And those are put in place there to basically separate themselves from the various components within the cluster, because in between that, you have different types of segregation between machines. And those are the green line that you see in this diagram. And then you have the data flow. So when you're creating your own trust boundary, you can actually use this trust boundary that was created by the upstream for Kubernetes, but then layer on top of this your application stack, because it's going to have its own trust boundary. And some of that will relate back to the components in Kubernetes, especially when you're talking about APIs. So it's going to be important that you create this map and then overlay your application map on top of it, because those trust boundaries and the data flow in between those is going to be where you're going to start doing your modeling for attack trees. So understanding critically how your data is flowing in between each boundary and each machine segregation is very important. So we'll dig into that a little bit further here. Go ahead and next slide. So attack trees provide a formal, methodical way of describing the security of systems based on varying attacks. Basically, you represent attacks against a system in a tree structure, with the goal as the root node and different ways of achieving that goal as leaf nodes. So this is perfect for Kubernetes attack trees. If you understand how Kubernetes is set up as a cluster, you'll understand that as you spread your application across the various leaf nodes, it becomes absolutely critical when you create this attack tree. I'm talking about the goal as the root node. Go ahead and go to the next slide. So here is, this is a number of attack trees kind of put together. So if it goes from top to bottom. It's we call it the top-down approach. Now there are various other ways of doing attack trees, but this is the top-down approach. It's probably the more common methodology for creating an attack tree. But essentially you're going to start with, in this particular case, we've started with a basic attack. In this case, it's exhausting compute resources. How are we going to do that? And there's different ways that we're going to approach that, from adding an extra process to a running pod within a Kubernetes cluster. How is the attacker going to do that? How is he going to accomplish that? Maybe they have a privileged container or an unprivileged container out there that they get access to. Then they spin up a process inside of it, and then they run amok on your Kubernetes cluster. Or maybe they get access through the client APIs in Kubernetes. Maybe they found a certificate that's available publicly somewhere that you put in GitHub, and now somebody's able to get in there and attack your system. They're able to get access, and now they're able to spin up extra pods to be able to exhaust resources within your Kubernetes cluster. A lot of these things can be accomplished, but there takes a little bit of ingenuity to be able to accomplish them. You'd be surprised at the vulnerabilities that do happen. There have been some major events in the Kubernetes world. Tesla had an event. I think there was another major one where they were able to get access, full access to the Kubernetes cluster just based on some silly things that were not locked down. That if they implemented an attack tree prior to deploying into production, then this never would have happened. So it's imperative that we take our applications and create these various attack trees. And you're going to create an attack tree based on the various boundaries that you saw on the previous map. You're going to make it based on the various data paths that have been created for your application. Absolutely critical. This is a very good thing to go through. Go ahead, next slide. The other thing that we want to address in this whole threat modeling, of course, is the skills gap. How do you learn how to do these attacks? How do you learn how to think like an attacker? And it really takes some hands-on effort. Takes time to be able to develop these skills and really think this way. It's not something that comes immediately. It takes some time. And from the CNCF in the upstream, there was some discussion about this and how we really wanted to go about this. And the ultimate goal was really to make it a multi-user experience, being able to teach both the red team, the blue team, and also be able to do forensics on the environment. Next slide. And that's where this simulator was created. So in the CNCF, they created this simulator which goes through, and this is all web-based. You can go to kubsim.io. You can also download the source code and run it directly within your environment as well. So you have multiple ways of doing this learning. But there are several different threats that it takes you through and helps you to understand so that you know how to model these threats in your own environment. So there's a list there on the right-hand side. So this is actually a really good way to teach your red team, teach your blue team about the various threats within a Kubernetes environment. So I would certainly urge you to use this tool. As things continue to mature, this simulator will get better, and there will be more. There will be more tools to help us to do more modeling, to be able to do easier modeling. There's already been talk about being able to create a tool that actually is designed to work within your workflow that helps you to easily map out your data, data paths, your boundaries, and then, export that into a nice format that you can read and visualize. These tools are already being worked on. Of course, none of this is done completely yet, but we're thinking about these next stages and how to make it easier for everybody. So pay attention to those things. Next slide. I think this is you.
Yeah. Yeah. So kind of on top of Kubernetes, typically if you're doing active development, you're probably going to either build your own or use a platform to be building your application. For example, Cloud Foundry. our version of Cloud Foundry would sit on top of Kubernetes and allow you to deploy applications that way, as well as build applications. So one of the things that gets you is that you pretty well know what the traffic patterns should be of this platform. So it allows you to lock it down a little bit tighter instead of having to, basically for every application, kind of reinvent the wheel. You can actually look at the components that you're going to be using ahead of time. For example, in this chart, this is the Cloud Foundry security model. And so you can see that there's obviously different components that talk to each other, but they're well known. The other thing that you will really need to know is, so Kubernetes uses what's known as role-based access control, or RBAC. And it is a least permission security model. So basically, you're going to get the lowest common denominator of permissions that you have been given. So there's three components in this that if you're setting up security for your Kubernetes, one is going to be gangway. That's going to do your actual authentication. The second is DEX, which gangway hooks into, which will do your authorization. So the authentication is basically, are you who you say you are? And then authorization is, what are you allowed to do? And then it passes that information over to the Kubernetes API, which will then do your admission control. So one thing that's important here is that if you're creating service accounts so that components inside of your platform can do actions or take actions against the API and say create objects, create more workloads, for example, you want to give those as few permissions as possible. Same with human users. You don't want to give everybody root on a normal Linux box. So you don't want to do the same inside of Kubernetes. There's a lot of tooling that will help you model this and actually be able to see what's going on inside that Cameron can talk about.
Yep, absolutely. Lots of third-party tooling. So Andrew talked, a little bit about the platform security there, and at a lower level, when you get down to the Kubernetes host where you're running your containers, you've got your container runtime, and there are ways to, lock that down even further. There's tools built into SUSE Container as a Service platform, such as AppArmor is one tool that's enabled by default to lock down the runtime environment. Another tool that's out there is called Falco. It's not well known, but it's receiving a lot of street cred. It was made by the SysDig guys, and it certainly allows you to actually lock down policy and do controls from a policy perspective on your container runtime. So another powerful tool to apply when you're applying your continuous delivery workflow. Another one is OPA, which is the Open Policy Agent. This is another one receiving a lot of attention right now, especially when you think of cloud native in public clouds and private clouds alike. You need a common methodology for both environments. This is going to give you that ability to apply policies both in public cloud and private clouds, no matter where you're running. Notary, of course, is there for your registries, being able to secure that. Another one is the Spiffy Spire. Spire is a format, or I'm sorry, it's the other way around. Spiffy is the format and policy, and then Spire is it's a tool that allows you to apply those policies and configure those. Spiffy Spire is getting lots of attention right now as well, and I would imagine that we'll see a lot more of that coming up here in the future as a general guideline for applying specific policy across your cloud native environments, both in the public cloud and private clouds alike. In-Toto does some similar things as well. Another tool that's more for public cloud policy, and a lot of people don't really understand that when you first develop your public cloud native environment, that things are really not well locked down from a cloud native perspective. You have to really pay attention to the policies that are there. Otherwise, you're going to lead yourself to being open. And that's really what Cloud Custodian was built for, because it actually goes out and does policy checks within your public cloud environments. All the major public cloud environments, from Google to Azure and Amazon. So it was built specifically for public clouds to really lock them down, so you don't have any open policies that can allow an attacker to get access to your environment. Another one is for SETI security. And there's more that I could add to this list, but this is really to help you get started in digging into this. You'll notice that if you go out to the CNCF Foundation, most of these are actually still in incubation. So you're going to see a lot of work going on within the next year or two in this realm of security. There are a lot of third parties that are paid for products that can help you there. You've got Aqua Security, you've got SysDig, and many others that have paid for tools that can help you in many of these different areas. Go ahead, next slide.
Yeah.
There you go.
So I want to finish up with basically some anti-patterns that I've seen a lot of companies, or at least a lot of documentation, be suggesting. And some of them make your life easier as a developer or operator, but will end up biting you in the long term because they're just not secure. So the first one is running with elevated privileges. Again, you want to have the least privileges available. So that means setting up, as part of your workflow, the right policies so that whatever workflow you're running only has the privileges that it needs. This is both service accounts for actually being able to create new objects or attach to databases, but also it means making sure that the OS is locked down and you're not like running on like the host network, for example, or passing in more volume mounts that you really need. The second one is similar. There's a lot of documentation and a lot of products out there that expect you to be passing in the Docker socket or your CRI to the containers, specifically for CI/CD. It seems to be a very common pattern. This is obviously very insecure. If you look at one of the attack trees that Cameron showed, it would be, reasonably trivial to add in scripts that run at install time or at build time for your containers that actually attach to that Docker socket that it's expecting, and then turn around and create workloads. The next is basically building in your dependencies into your runtime container. So fairly early on, Docker had the ability to do multi-stage builds. And then with tools like Builda, which is one that is more specific to the CRI, basically you want to have as little code or binary in your container as possible. For obviously, the more code or the more binary, the more surface that there is to attack. Next, you have basically trying to control too much of the platform. So to some extent, you have to trust the platform and the platform builders that they know what they're doing. And then if you are going out, basically out of bounds of what the platform expects, there's a good chance that you might be opening up holes inadvertently. I mean, just in general, you don't tend to want to build your own security because you're likely going to make a mistake. So for the same reason, you probably don't want to be building your own platform because there's a lot of things to think about. So if you give up some of that control, you end up with a lot more security. The other is, another is running more than one service in a container. So there's a lot of times that you'll see people running say Monet or another init script that actually goes and then runs like 4 or 5 programs in a single container. Don't do that. You want to have one application or one service per container, and then you can use Kubernetes to actually control how the containers can talk to each other. This will allow your security tooling to know what is supposed to be running in that container. Because again, if you have more than one service running, you're just going to be adding additional confusion later on. And then the last is file-based logging. So if you are logging to files, those files can be read. And if you're logging to files that are outside of the control of whatever platform you're using, they're also outside of the security controls from whatever platform you're using. A lot of newer applications and a lot of newer models for building applications, if you just log to standard out, the platform can take that and in a secure way route it into a place that you can view your logging from. There's obviously a lot more. There is a huge amount of information here, and it'd probably take a week to go through all of what you could figure out for security and what you really need to know. But hopefully this was a really good introduction and useful to get started and learn what you're going to have to know basically to get started with the platform.
Yeah, absolutely.
Yeah,
thank you, and thanks for watching. Let's make security awesome. Let's get everybody involved.
So very important.